So today we're going to start conic sections. Remember that we have a class today and we'll go over the ellipse, and then that's it for the rest of the week. You'll have your exam. It will become available on Wednesday at 12 a.m. and then it'll expire on Thursday at 11:59 p.m. So you'll get the 48-hour window to take it. I like conic sections. The only time I ever really saw it was like pre-calc in high school. So, but we'll need this moving forward for the calculus sequence. So first half of this chapter is going to be conic sections. A conic section, they're curves that result from the intersection of a right circular cone and a plane. So there are 4 different conic sections: circle, ellipse, parabola, and hyperbola. The circle happens when our right circular cone is intersected by a plane and the plane is parallel to the base. We're going to get this perfect circle. Although we're not really going to talk about circles in here because we've discussed that previously. We already know everything we need to know about circles. An ellipse happens when the plane intersects that right circular cone at a diagonal, and so we get this oval shape. But you'll notice that both sides of the plane are totally within the cone. A parabola happens when the plane intersects that right circular cone at a diagonal, but one part of the plane goes off the base of that right circular cone. That gives us a parabola. And then a hyperbola occurs when our plane intersects this right circular cone perpendicular to the base of the cone, and we get it looks like a double parabola. Here, we're gonna see if my sometimes they do. I'm not feeling good about it. Nope. All right, maybe I'll send you some videos. Just cool things. You know, the more math you learn, you start seeing math everywhere, and ellipses are one of those things that you just start seeing everywhere. All right, so an ellipse is the set of all points P in a fixed plane, the sum of whose distances form 2 fixed points, F1 and F2. These are constant. These 2 fixed points are called the foci, or, the singular term is focus. The midpoint of the segment connecting the foci is the center of the ellipse. All right, so I feel like that all sounds so complicated. So an ellipse is just an oval. It has a center to it. The ellipse can either be big side to side or tall up and down. I don't even like that picture. I'm going to go to the next picture and then I'm going to come back. The line through the foci intersect the ellipse at 2 points called the vertices. So we've got these fixed points, these foci, and then they're on the same line as the vertex. The line segment that joins the vertices is the major axis. Please notice that the midpoint of the major axis is the center, and the line segment whose endpoints are on the ellipse and that is perpendicular to the major axis is called the minor axis. All right, so you have this ellipse. Whichever way it's long, that's your major axis. And whichever way it is short, that is your minor axis. Your foci always lie on your major axis as well as your vertices. Now we know with circles, knowing that standard form is like the most important thing because we can't do anything else otherwise. That is true with our conics as well. So here's the standard form of the equation of an ellipse. We have one for horizontal and one for vertical. A squared is always larger than B squared. You'll notice that it really does look a lot like a circle, right? x minus h squared plus y minus k squared equals something. So a lot of this is very, very similar to a circle. The center is HK, the major axis has length 2A, and the minor axis has length 2B, and the foci are C units away from the center along the major axis, where C squared is equal to A squared minus B squared. I feel like I'm saying a lot, but once we start doing these, you'll see, especially ellipses, super easy. Super easy. I don't really like to remember more things than I have to. You know that about me. So I don't want to have to remember two different standards forms for the ellipses, depending on whether it's horizontal or vertical. So since a squared is always greater than b squared, I always just remember that whichever variable has the larger number on it, the ellipse is going to be long in that way. So if the big number is under the x, then I know that it's big in the x direction, so it's going to be a horizontal ellipse. If the big number is under the y, then I know it's big in the y direction, and I'm going to end up with a vertical ellipse. So we are going to graph this, state the center, the vertices, and the foci. You'll notice that we don't have the parentheses like we have here in our standard form. So that tells us that our center is going to be the origin. All right, there's my center. Now, it's said that our major axis has length 2a and our minor axis has length of 2b. And our standard form shows us that the denominators are a squared and b squared. So again, this is going to be super easy. All you do, I'm going to take the square root of the number under the x. Square root of 64 is 8. So from the center, I'm going to go 8 in either x direction, since that's under the x. And I'm going to make some points. Then I'm going to take the square root of whatever number is under the y, and from the center, I'm going to go that many units in either y direction. So the square root of 100 is 10. I'm going to go 10 up. I'm going to go 10 down. And now I have the points to draw in my ellipse. I actually draw it in before I answer all the questions. I do that with most of the conics. And there we go. That's it. Last thing we need to do is state the vertices and the foci. The vertices are the points on the graph that our major axis intersects with the graph. Well, the big number was under the y, so the 2 points that I went up and down on the y, well, those are going to be my vertices. So 0, 10, and 0, negative 10. And then we need to find the foci. This is the most work. We've got to use this little formula up here that says that the foci are C units away from the center, where C squared is equal to A squared minus B squared. Now, as we move through these conic sections, they all have a standard form that looks really similar, and they all have foci that we need to find. So how I remember it is, if my standard form, if my equation has a plus in it, then finding my C value has a minus in it. Because later when we do hyperbolas, it's the exact same standard form, except this is a minus up here, and this is a plus down here. So I was just remember that it's opposite the operation I see from the equation to finding my C value. So my foci, C squared is equal to a squared minus b squared. So basically, I'm just taking the big denominator minus the little denominator. We get c squared to be 36, so that means that c has to be 6. Our foci are on our major axis, c units away from the center. Here's our major axis, then c, we're going to move away from our center that many units. Here we go. Here we go. And those are our foci. That's the point 0, 6, and 0, -6. That's it. I feel like it's easier than all those words make it sound to me. Questions at all?
Ms. Kraft, what would those foci represent?
I'm gonna Google a damn video that I want to show you guys. And my kid's email from his teacher. So, you know, like when you make a circle, if you went like old school with it, you put a pin in the center and a string, and then you like trace it like a compass, and then that's how you make it. Well, the foci are the same thing for your ellipse. Here, watch this video. Oh my gosh. So the foci are the points by definition. If we go back and really look at the definition of our ellipse, it says, geez, man. So, okay. Definition of a circle says a circle is a set of all points a fixed distance away from a fixed point. The fixed distance is the radius, the fixed point is the center. An ellipse is the set of all points, the sum of whose distance from, that shouldn't say form, that should say from, two fixed points is constant. So looking back at this video, this distance has to remain constant. So it's a set of all points that are a fixed distance away from two fixed points. And those two fixed points are our foci. Does that clarify it at all for you?
Yeah, thank you. That makes a lot more sense.
Yeah, that's what my video was supposed to be. I don't know why I didn't link. Never wants to link out of OneNote, but usually when I'm live in class, I just pull it up on the desktop and then play it that way, but it didn't allow me to do that. So, okay, great. All right, let's do another one. So you'll notice in this next one, it's not quite in standard form. With all our conic sections, we always want it to be equal to 1. That's how we know it's in standard form. So it's not equal to 1. The very first thing I'm going to do is divide everything by 100 so that I am equal to 1. X squared over 25 plus y squared over 4 is equal to 1. So is this going to be big in the x direction or the y direction?
The x direction?
X direction, because the big number's under the x. So that's pretty straightforward. We can identify our center right away. What's our center going to be?
Origin.
Going to be the origin. All right, so I'll plot that. And now to graph our ellipse, we're going to go how many in the x direction from the center? Right, take the square root of whatever is under the x, and that's how many you should go side to side in the x direction. So the square root of 25 is going to be 5. So we're going to go 5 to the left and 5 to the right from our center. How many are we going to go in the y direction?
2.
2. All right, now once we have these 4 points, we just connect the dots and do our best to draw in an oval. Mine always look like eggs. All right, and there we go. Now we want to go back and answer the rest of our questions. We want to find our vertices. Well, our vertices are kind of the end points in the long direction on our ellipse. So that's what? -5, 0, and 5, 0. And then our foci, well, we need to find our c value. Because our equation was plus, I know to find c, I'm going to minus. That's going to be a squared minus b squared. Also recall, the foci have to be inside of the, oh my goodness. The foci have to be inside of the ellipse. So if you accidentally add a squared and b squared, you're going to get a c value that puts you outside the ellipse. So that should red flag you that there is a mistake. All right, so c squared, it's always my big denominator minus my little denominator. C squared equals 21. So c is equal to the square root of 21. And the foci are located along the major axis, c units away. So it's going to be like here and here. And now we just need to write that as an ordered pair. Since it's a horizontal, because soon we're going to get our center off the origin, because it's horizontal, it's the horizontal component of the center that you add the c value to. So we're going to have negative square root of 21 comma 0 and positive square root of 21 comma 0. Questions at all? Right, it's not so bad. So now we want to write the equation of the ellipse having foci -5, 0, and 5, 0, and vertices of -8, 0, and 8, 0. We are going to be using our standard form. So whether it's A or B on the bottom, well, you're going to look at your foci and your vertices. Notice that your foci and vertices are x values. So that tells us that our major axis goes along, horizontally. So that tells me that my big number, A, has to be under X and B has to be under Y. So the first thing we need to do is find the center so that we can plug in and start writing. What is our center going to be? Any ideas?
Origin.
And how do you know it's going to be the origin? You're correct.
Well, there are zeros there.
I'm sorry, guys. When I say get your brother and he just yells, that's not so good. I'm sorry, give me 1 second, guys. Seriously, go get your brother. Now. Oh my gosh. Okay. So Anna, what were we saying? How do you know that it's horizontal and that well, we know it's horizontal because we kind of just mapped it out, but how do you know that the center is right at the origin?
Well, because everything goes to zero, like faucet goes to zero and the vertices goes to zero, and that's the
Right. Your
center.
center is always going to be the midpoint. It's going to be the midpoint between the foci or the midpoint between the vertices. So yes, correct. One second.
Yo. Hi, everybody.
Uh,
How's it going?
Okay, sorry guys.
it's Monday morning.
Oh, this homeschooling thing is super fun. All right, so now we got to get the denominators. So the big number is going to go underneath of the x since it's opening in the horizontal, and that's where our foci and vertices are. So remember that our major axis is whatever this number is, the square root of it times 2. So any ideas of what we might put under there?
64.
And how are you coming up with that 64?
8 squared.
Right, so we're going for 8 to the left and 8 to the right from our center. So A is going to be 8, and then we just have to square it. That's going to give us 64. But now we need to figure out what number goes under the y. And that's where we're going to use the foci, because so far, really all we've used is the vertices. We're going to use the foci to figure out the number under the y. We know that c squared is equal to a squared minus b squared. We know our c value because we've gone 5 in either direction from our center to get our foci. So we know that our c value is 5. We know that a squared is 64, and we're just going to plug in and figure out what b squared is. Also, to kind of be able to red flag yourself whether or not you've made a mistake, your a squared and b squared should always be positive. So if you're doing this and you end up with something that's negative, then you know that there is an issue. So let's solve it. What's that? 64 minus that 39. That's a negative 39 equals negative b squared. We divide, we get b squared to be 39. I wouldn't even bother trying to, square root this because we're just going to square it when we put it underneath the y. So there we go. Questions at all? All right, so let's start moving the center off of the origin. It's the same thing. We just got to be a little more careful counting our points. We'll start by identifying whether this opens whether it's long in the x direction or long in the y direction, which is it going to be?
X direction.
It's going to be long in the x direction because we've got the big number underneath of the x. Next, we will identify our center. What is our center going to be?
Minus 2, 3.
And exactly, just like our circles, we're doing opposite signs going from the equation to the center. So I'm going to plot my center. And now we'll get our 4 points around the center. We're going to use the square root of the numbers underneath X and Y to figure out how to make our 4 points. So the square root of 16 is 4 from our center. I'm going to go 4 in either X direction. And then square root of 1 is 1. We're going to go Y in either 1 in either of the Y directions from our center. And then we draw in our oval. Questions on drawing the ellipse?
Don't we need the foci on that one?
Say that again.
Don't we need the foci?
Oh, yeah. I was just talking about the graph. I'm ready to answer all the questions. So we are going to first list our vertices. Our vertices are the endpoints in whatever our long direction is. So what are our vertices this time?
-6, 3, and 2, 3.
Great. And then we need to identify our foci using the fact that c squared equals a squared minus b squared. So c squared is 16 minus 1. We get c to be the square root of 15. And our foci are along the major axis, so they're going to be like here and here. So we need to figure out which coordinate of the center we're adding that square and subtracting that square root of 15 to, so that we stay along our major axis. It's long in the x direction, so we're going to be adding and subtracting it to the x coordinate of the center. And personally, I'd usually just write this as one set of ordered pairs using a plus or minus. I would rewrite this -2 plus or minus square root of 15, comma 3. Although I'm sure that is not what my math lab wants. I'm sure. So I guess I shouldn't show you my notation since you're going to be taking all my math lab tests. But I would definitely just use the plus or minus notation. But I'm sure my math lab will make you list out the two. Questions at all? All right, so right now let's get to the bad ones because we knew it couldn't be that easy. But it's actually not that bad. It's stuff we've already done because we're already so versed with circles. Here we have an ellipse in general form. Just like circles, we're going to have to complete the square to transform our equation from general form to standard form. Now, you'll notice right away that our leading coefficient is not 1, and we have to have a leading coefficient of 1 to be able to complete the square. But you'll also notice that our leading coefficients are different. And in college algebra, or maybe even when we covered circles in here, I said, well, if your leading coefficients aren't the same, then you don't have a circle, right? Because before we were just dividing through everybody by whatever that leading coefficient is. Well, we can't do that here because I need the coefficient on both x squared and y squared to be 1, and they're different. So the way that we have to complete the square might be slightly different than what you're used to, but it's still the same process. All right, so also, I know this is an ellipse because, of course, I'm going to scramble up all the conic sections. And, of course, there's going to be ones where you have to complete the square. I know that it's an ellipse because both x squared and y squared, I'm sorry, let me see. Both x and y are squared, and the sign of the leading coefficients are the same, either both positive or both negative. That's how you know it's an ellipse when it's all written out like this. Because like I said, we're going to have other ones next week, or maybe it's a minus in between, maybe only the x is squared, things like that. All right, so I'm going to get organized to complete the square just like normal. I'm going to get my x terms together, leave a space, get my y terms together, leave a space, move my constant over to the other side. Now, with circles, we divided by whatever the leading coefficient is. With our conic sections, the other three conics, instead of dividing to change our leading coefficient to be 1, we're actually going to factor that leading coefficient out, just of this pairing. Still leaving my space. Everybody okay with what I've done so far?
In the parentheses after the 9, it should be y squared.
Oh, yes, thank you. Anybody else? All right, well, let's complete the square like normal. I'm going to start by grabbing the b value for x. I'm going to take b, divide it by 2, and square it. We get 16. So we're going to add 16 to make a perfect square trinomial. Here's where it gets a little tricky, though. Right? So add 16 on the left to create a perfect square trinomial. I know I have to add 16 on the right to keep it legal, but we're not actually adding 16. See, the value of the constant on the left-hand side is not just 16. It's actually 4 times 16. So when we go to add on the right-hand side, we have to distribute whatever we factored out to the constant that we found before adding it. So we're actually adding 64 over here. That's where I see the most mistakes, is that people just add 16. Any questions on why we have to do that? Does that make sense? All right, well, let's do the same thing then for our y's. I'm going to grab its b value, which is 4, divide it by 2 and square it. So that's 2 squared, which is 4. I'm adding 4 here to create my perfect square trinomial. What are we going to add on the other side?
36.
You got it. 36. Great. All right, let's get this into factored form. Remember that our perfect square trinomials always factor into the form x plus b divided by 2 quantity squared. So we got our 4 on the outside, and our perfect square trinomial turns into x minus 4 squared. 9 on the outside, and then our other perfect square trinomial turns into y plus 2 squared. And then adding those up on the other side, that's 64. That's 36. All right, but we're not quite in our standard form yet. Remember that standard form, this number here has to be a 1. So I'm going to make it a 1 by dividing everything by 36. Now, not always, but usually this simplifies nice. and you end up with 1 in the numerator and then just some other number in the denominator. I mean, you're not guaranteed that. So if this did not simplify down, like if this was, well, sometimes it doesn't. Sometimes it'll simplify down and you'll get like 2/5. That you can't have a 2 in the top, so you have to take that to the denominator, and this would actually end up being like 5/2 on the bottom instead of 2 on the top and 5 on the bottom. So sometimes it doesn't simplify as nice as this. If it doesn't, make sure that you only put it in the denominator. All right, but this one's nice. We get x minus 4 squared over 9 plus y plus 2 squared over 4 equal to 1. And now we're in our standard form that we can graph our ellipse. Is this going to be long in the x direction or the y direction?
X.
In our x direction, because we got the big number under the x. Next, we want to identify our center. What's our center going to be?
Four, -2.
4, -2. Plot my center. Well, how many units are we going to go in the x direction from our center?
Three.
There we go. Square root of 9 is 3. And then how many in our y direction? Square root of 4 is 2. So we're going 2. And we're ready to draw it. Okay, there's our ellipse. Our vertices, there always are endpoints in the long direction. So those are located at 1, -2, and 7, -2. And then lastly, we want to find the foci. C squared is equal to a squared minus b squared. So c squared is equal to 9 minus 4. C squared is equal to 5, making c equal to the square root of 5. And now we need to add and subtract the square root of 5 from which coordinate of our center?
Four.
It's long in the x direction, so we need to add and subtract it to the x coordinate, which is the 4. So we're going to have 4 plus or minus square root of 5, comma -2. And there we go. Questions at all? I feel like all the definitions and stuff are way more complicated than actually executing the problem. You complete the square if you have to. That's the tricky part, of course. And then you identify your center. You take the square root of each denominator and go in the above direction that many units. You connect your 4 dots. You look for the vertices. They're the ends in the long direction. And then you find your foci. And just make sure to add it to the correct coordinate on the center so that it stays on the major axis. That's it. Might ask for the domain and range as well, so just make sure you're watching the directions and doing what they're asking you to do. There are some awesome application problems that we can do with conic sections. So I enjoy these very much. A semi-elliptical arch supports a bridge that spans a river 20 yards wide. The center of the arch is 6 yards above the river's center. Write an equation for the ellipse so the x-axis coincides with the water level and the y-axis passes through the center of the arch. As always, a good picture is imperative. Oh, I forgot to mention at the start of today. So we're finally starting the 3 chapters of new material for us. Oh, none of this is going to be review from 103 or 104. We're going to hit parametric equations at the end of this. So I guess that's review from 104. But from here on out, it should be new material. So if you have questions, make sure you're asking them because you would have only ever seen them in a high school class. All right, so a semi-elliptical arch supports a bridge. So it's a bridge that looks my water. So it's one of those kind of bridges that the semi-ellipse supports the bridge, not that the bridge itself is shaped like an ellipse. All right, it says that this river is 20 wide. Now hold on about filling in your diagram. You may change the way you want to write it because I'm going to erase some stuff. So we know it's 20 wide. It says that it is 6 tall. And we want to write an equation so that the x-axis coincides with the water level and the y-axis passes through the center. Even if the directions did not say that, I would totally do this. When writing the equation of any of these conics, it's always easier to have the center at the origin than to have it at some point off of the origin. So what we're doing is we're just going to kind of put the Cartesian plane in a place where it forces that to happen. I lay my axes, say that's our x-axis, and this is our y-axis. It'd be nice for the center of our ellipse, right, because this would be the rest of it. It would be nice for the center of the ellipse to be at the origin. So we're just going to put our axes there so we can have that. So that means the top is going to just be x squared plus y squared. All we need to do is figure out the a and the b. Well, they tell us that the bridge is 6 feet tall at the center. So that tells us this is 6. And then it also tells us that it spans a river 20 wide. So that means that this part is 10. Well, there's our A and our B right there. Remember that we will have to square it. Now, it was important that I cut it in half, by the way, this 20, because we know that the major axis is 2A and the minor axis is 2B. So it's important that we just take half of it there. And then we're going to square those numbers and put them under the appropriate variables. So the 10 is in the x direction. I'm going to square it and put it under the x. The 6 is in the y direction. I'm going to square it and put it under the y. And that's it. Questions, anybody? Okay. A hall 100 feet in length is to be designed as a whispering gallery. So a whispering gallery is one of those rooms that like you can stand super far apart from somebody and talk real quiet and you can hear them as if they're standing right next to you. Now, when they tell you where to stand with those whispering galleries, where you're standing are the foci of the ellipses. I mean, the word focus And you know, mathematicians are not creative with their vocabulary. That's because that's where the sound or the energy or whatever is focused. I think it'll make more sense when we do the application problems with parabolas and we talk about satellite dishes and flashlights and things like that to focus things in. That energy or that sound has to be at the focus. So with a whispering gallery, you're standing at the focus. All right, the foci are located 25 feet from the center. How high will the ceiling be at the center? We want to round to the nearest 10. Well, even though they didn't say anything about the x-axis coinciding with the floor and the y-axis being in the middle of the room, you want to do that every time. It just really makes your life so much easier. So here's the floor, and I'm making it coincide with the x-axis, and then I have this semi-elliptical room. Put my axes in. So the hall is 100 feet in length, so that tells me that this much is 50. I could even write an ordered pair, I guess, if I wanted. With some of the applications, that ordered pair is helpful. They tell us that the foci are 25 feet from the center. And we want to figure out the height of the ceiling. And I'm going to label it Y just because it's in the Y direction. All right, well, that's everything we know. Any ideas on what we should do? All right, well, we're going to see this kind of recurring theme in these application problems with the conics. Either it's going to be an application like this, where it's just asking you to write the equation, or it's going to be an application problem like the other one, where what we're going to have to do is we're going to have to write the equation like we did in this first one, and then answer a question based off of that equation. So we need to write the equation and then answer the question about how high the ceiling will be at the center. Well, I know that it has to be long in the horizontal direction. And why do I know that?
Because of the foci?
Because of the foci. The foci are on the major axis. The major axis is going across. So I know my big number is going to be under the x. And we put the center at the origin. So I know I have just x squared and y squared on top. What all do we know? Because we need to know both a squared and b squared. Do we know either of those?
X squared will be 2500.
You're right. What goes under the x, we're going to take 50 and square it, 2500. And just like in the previous example, what did we have to use to find the other denominator?
That's U square formula.
Oh my gosh, how can I make my phone turn on? Sorry. Yeah, we're going to use our foci in our little formula. We know that our C value is 25. So 25 squared equals, we've already established that a squared is 2500 minus our b squared. So 625 equals 2500 minus b squared. Can somebody do that subtraction for me, please? Is that 1375?
1875.
Yeah, like that does not seem right. Thank you. All right, 1875 equals my negative b squared. So b squared is equal to 1875. I'm not even going to waste my time square rooting that since it's b squared underneath. So we get this right here. So that's our equation, but we still have not answered the question quite yet. It wants to know how high the ceiling is going to be at the center. What's it going to be? How do we know?
The square root of 1875.
Yeah, it turns out this is actually our b value. So the height equals b, which is the square root of 1875, and our directions say round to the nearest tenth. So just pop that in your calculator.
43.3.
43.3, and our unit is feet. Oh, there we go. Questions at all?
So in this kind of problems, there's always going to be one, like equals to 1, the equation.
Yes, your standard form is always equal to 1 with all the conics, all 3 of them that we're going to do. Anybody else? Questions? Because that's it for today. That's an ellipse in a nutshell. Nope. And anybody? Questions at all?
I don't have a question, but I do have a comment about accessing your course notes because I attempted to do that over the weekend.
Oh, like the videos or completed course notes?
The completed course notes.
Yeah, you probably can't access them at all, can you?
No.
Okay. Yeah, remember when I told you I accidentally deleted them all off of OneNote? Because I texted you and said, what page are we on? Yeah, I just never relinked it up. I thought because I had the videos, you guys wouldn't necessarily need them. It's a quick fix. It'll just take me a minute. I'll just rehook up that link.
Okay.
Skimming through the lecture videos is pretty easy too.
Yeah, the videos are, I use
If
those
you have to
over the
like go
weekend.
back and rewatch something.
Okay. Anybody else?